is going to be just as fun. But when we make this picture, the sinusoidal is going to be sideways. So you may want to rotate your paper as you look at it. I'll explain it in just a second. Okay, so here we've got to figure out what's going on. So Tarzan is swinging on his vine for Jane. As he swings, he goes back and forth across the edge of the riverbank, going alternately over land, over water. Jane decides to make a model of his motion, and as she starts her stopwatch. Let T be the number of seconds as the stopwatch goes. Y be the horizontal distance, and Tarzan is from the edge of the riverbank. Assume it's sinusoidal, and this is where we need to make sure we read positive when he's over water, negative when he's over land. Okay, so here is basically what's happening. So we've got this picture here, and we will come in and put times in here. You guys need to see this is as far out as Tarzan can swing. So this is kind of like the bottom of our graph. And here is as high out as he can go. This would be the top of our graph. Remember I told you that it's sideways? And just because to me this makes sense, here is the riverbank. So when he's to the left of this blue line, here he's in negative land when he's over land, and here he's positive when he's over water. And that was what we had read up above. Okay, so that gives you an idea of what's going to happen. So we've got to have some kind of a start. So this is where I am going to start the clock. That's where Jane starts it. Jane observes the stopwatch, reads 2 seconds when Tarzan is at one end of his swing, and notice it's the negative. So he starts, and the first thing when he maxes out on is this negative number, and that happened at 2 seconds. So I automatically know this is the point 2, negative 23. He then swings back, and at 5 seconds, he's at the other end of his swing. And notice that it is positive. Oops. And that's going to be right about here, and that's at 5 seconds. He's at positive 17. And then he would swing back and forth. Oops, it's supposed to be curved, but it's hard to do this on my machine. Okay, so you guys get the idea. We're going to leave that be kind of crazy for a second. Okay, so notice he was positive, positive, negative, got it. It says sketch the graph of the sinusoidal, label critical points, then determine the period and the amplitude of the sinusoidal and the A, the B, the C, and the D. Okay, so I'm just going to make a little list here. A, B, C, and D, since it's specifically asked for those types of things. So now we've got to start to look at some things. And I remember my C value is where I know a cosine wave starts. This would be my first real point that I know. So this would be my phase shift here. So I automatically know my phase shift is positive 2, which means I'll use negative 2 in my thing. Second thing, I see I'm going from negative 23 to 17. This blue line is not my D value. So I am going to have to do my little trick for my D value, my negative 23 plus my positive 17, and I'm going to divide that by 2, and that gives me negative 6 over 2. So my D value is negative 3. So in reality, this line right here is my x-axis. Okay, I got my x-axis. It's in green. Okay, so I've got my C and my D. Now that I know that C and D, that axis, how far is it this way and how far is it this way? If this is -3, can you see that this would be 20 units? And -3 and +17, this would be 20 units. So can you see that my A value would be 20 units? Now the last one, you know it's going to take a little bit of work. So I know 2 points, and I look, if I turn this sideways, this would be half of a cosine, I don't know if it's going to let me keep writing, wave. Okay, so I've got half of a cosine wave. So from 2 to 5 is half of a cosine wave. So do you see it takes 3 seconds? So one wave, it would take 6 seconds to finish. So that would be my period. Okay, so my B value is 2 pi divided by my period, or my B value is going to be pi over 3. Okay, so we've got all of our stuff done. So part B says write an equation. So my equation is going to be y equals, and we've been talking about it being a cosine wave. This is negative. Oops, something that I did not mark down, but I see, you guys see that this is flipped, that it starts in the negative land. So it's going to be -20 cosine of pi over 3, theta subtract 2, and then minus 3. And again, remember the theta is the same as small lowercase t in this case. So if you want to put in t, that's okay. So now you're going to grab your calculator, and all you're going to do is plug in your t value. So this one would be y equals -20 cosine of pi over 3. And again, when you're putting this in, you need to put that parenthesis there, and then you're going to put a parenthesis here of 2.8 subtract 2, close those parentheses, minus 3, and hopefully you come out with negative 16.38 meters. I want you to try the next ones, plugging in t the same way. I believe that this one would be positive 1.16 meters, so you know it's over the water. And this one, the last one, should be negative 13 meters. That means that it's going to be over land. Okay, so the next one wants us to know where was Tarzan when Jane started the stopwatch. Starting the stopwatch, that's time equals 0. Do I do exactly what I did up above on the other questions? Plug in 0? Yes. And your answer should be 7 meters. And it is over the water. Even though my picture didn't show that, it's supposed to be over the water because it was positive. Okay, so for this last question, I am going to type out directions like I did before. It is going to be a Word document that you're going to read. Follow the directions, input it just like I tell you. Basically, you're graphing 2 lines and you're finding where they intersect. So, good luck, everyone.